All right, so ladies and gentlemen, we'll get started again. It'll be nice if we can all get back to our seats. I'll just give another minute for everyone to settle down, and then we can proceed to our next session. So for our next session, the topic of presentation is industries leveraging blockchain successfully and the key applications. And I'd like to invite Ms. Ankur Maheshwari, Director of Research at Techracers, for this event. Sorry, Mr.
No problem. Thanks. Hello. All right. Hi, I'm Ankur. I'm the Director of Research at Techracers. We are an end-to-end blockchain technology service provider, so covering the entire spectrum, right from advisory and consultation to development to DevOps and everything. Because we are a technical solution provider, that gives us a chance to work with several verticals. And I know this is more about fintech, but I thought it'll be good to explore some other use cases of blockchain in some other industries. So this is just a sort of fact sheet, which tells us about the amount of revenue raised via several ICOs in other verticals except fintech. So apart from fintech and infrastructure, the three key segments are healthcare, social media, and telecom. And that's the revenue raised till 2018. So as you can see, that's quite a substantial amount. All right, so we'll cover the sector one by one. I'll first get into healthcare and what are the sort of challenges that blockchain is solving for healthcare. These are some key facts, some of the problems that are actually plaguing the healthcare industry at the moment from a technical standpoint. The hacking is one of the biggest problem. So health data, which is very sensitive and very critical and private, gets crypto hacked. Then the insider attacks, basically sharing up of personal information to pharma companies, that's another problem. The out-of-pocket health cost industries for data reconciliation and all of that. And then fake drugs, provenance problem. So drugs not being tracked properly throughout their entire journey. And then the health transactions, which I earlier mentioned. So what are some of the cases that blockchain can possibly solve here? One is obviously interoperability and patient data management. So you have several of these healthcare providers who actually store data in different formats, and blockchain can sort of bring all of that together. Then there's obviously provenance, drug supply chain integrity, and then insurance claim. Those are some of the key areas where I feel blockchain can add a lot of value. Excuse me. So we'll cover this one in a bit of details. So right now, if you take, for example, the landscape of health data in USA, so you have several of these EHR providers who actually store data in different formats altogether. And then as a patient, you need to store data in each of these hospitals. And if you go from one hospital to another, there's no way for you to sort of take your data away. Besides that, there is also the challenge of the data getting crypto attacked. So the entire data can get encrypted, and there's no way you can actually get your data out. This is one problem area that we have actually partnered with a company called Patientry and solved it using blockchain. So I'll get into the details of what the solution is. So imagine now that instead of you having to maintain your health record data in different hospitals, you can have just one application that stores your complete health data. And then your health data, instead of being stored in just one place, is actually sharded and encrypted so that it can never get crypto attacked. That's what blockchain sort of does for you. So you have this data that's stored in a place. You have every patient or every user has his or her own wallet, and then has their identity on the blockchain via which they store that data. The data then gets sharded and replicated across multiple data centers so that there's never a single point of failure, even if a particular data center fails. And then you can very easily retrieve data, and if you want, you can then use the blockchain to share the specific portion of your data with some other provider. That's what interoperability and patient data management is all about. So in one go, you solve the issue of privacy of data, you solve the issue of access of data, you solve the issue of interoperability, and you solve the data privacy issue. The testnet for Patientry actually went live last month, and now we are collaborating with several of healthcare providers to quickly bring them on board. And we are not challenging the legacy system as such. We are trying to bring the legacy system in together, integrate with them so that a patient can use both of it, but slowly it's going to transition over into the complete health data will come onto the blockchain. So that's that. Then drug supply chain integrity and provenance. As we all know, fake drug is a huge problem. To track where the drug is made, how it was supplied, who manufactured it, how it was transported, and then is it actually reaching the final end user or the final customer the way it is supposed to be, needs a lot of technological help. So that's where blockchain comes in. Like the immutability aspect of blockchain is the perfect technical fit for solving a problem like the drug supply chain or the fake drug problem. And not just the fake drug problem, actually. It's also about the funding. So for example, let's say if I own, for example, Bill and Melinda Gates Foundation, right? They want to fund a hospital in Africa. How are they ensured that the money that they actually gave in went to the hospital and was not siphoned off in the between? So even tracking of the health funding, even that's a very good use case of blockchain. So here also, we are using the technology to completely track every penny that's going to get funded and every drug that's going to manufactured, and from the manufacturer to the wholesaler to the retailer to the patient, and then also take validations at each and every point via blockchain and IoT integration. So we're working with, we're partnered with Connect on this, and then this is going to get demoed to World Bank, and if the proof of concept succeeds in a manner, then we're actually going to take it multi-stream across country borders. So that's about drug supply chain. Insurance claim, we are all aware about how blockchain can help insurance. If you have the patient's complete data and the history of their data stored in one particular vault, it becomes very easy to sort of analyze as to what were the disease that the patient went through. The claims become much more easier to process. And then when you bring all of this together in the blockchain, the same data can then be transferred over to multiple insurance agencies as well. So that's another use case of blockchain. And then if you bring smart contract into the mix, you reduce all of the transaction fee and all of the processing fee that you currently have to go through. All right, yeah. So another use case is social media. We're all aware about the Cambridge Analytica thing that happened with Facebook, and the recent push by pretty much all the governments towards GDPR and privacy of data. Right now, the only people who actually make money from all our social media activities are these centralized companies like Facebook and YouTube. Blockchain has the potential to change all of that. It can give the ownership of the content and of the content that you create. You should be the one owning it, and you should actually have a share of all the revenue that these platforms make from it. So that's we have put some of the facts over there. Over 75% of all internet users use social media. I mean, that's pretty common sense. Cambridge Analytica, we all know what happened there. There's a post every 3 seconds. That's a lot of data that's being generated. Data that's very private, and data that sort of is then put onto all these data lakes and used and sold to all the marketing agencies. So how can blockchain help here? Personal data exploitation. As I mentioned, you should be the one owning your data, and your data, if anybody chooses to market it, you should be the one who should be getting a percentage of revenue from it. That's where blockchain can come into the picture. Reward distribution. So let's say I am a nano influencer. I run a cooking channel, and I have thousands of people following my cooking channel. I should be able to promote anything that I want into that particular channel, and then be rewarded for it. And then authentic content distribution. fake news or like fake post making the rounds on Facebook, WhatsApp, Telegram is now quite common. There needs to be a way that you can actually authenticate whether the content is correct or not. In fact, in India, it's a pretty big problem where fake post can actually lead to riots and a lot of mishappenings. Blockchain can solve all of that. So I'll first come to like the personal data exploitation. So if currently when you store when you're using Facebook or Instagram or any of that, then you are not the one who's owning the data. The moment you share the post or the moment you create the content, it's the internet providers who actually own the data, and from there on, like they choose to use your data in the way they wish is best for them. Imagine now that you can actually have all of this data, and then instead of Facebook owning it, you have your own private vault where this data is encrypted, and then you can choose as to whom you want to sell this data to. Even if you want to sell it or not, like you can control who has access to your data. Reward distribution. So let's say I'll go back to the earlier example that I gave. Let's say I'm running a YouTube channel with let's say 1,000 followers. What if I can do ICO of that channel itself? What if I can actually raise money from other people and then give them a share into my reward pool and basically run a Nike campaign or run a Reebok campaign or run any other campaign to my followers? That's exactly the sort of problem that we are trying to solve with Howdo. So we have partnered with Howdo, and we are trying to make a universal social application platform that's going to be powered by blockchain. Now, one of the biggest problem here is obviously the scalability issue, right? Social media, like something like Facebook, Instagram, you're going to have like millions of transactions per second. And right now, there is no current blockchain that can support millions of transactions per second. Yes, there are a few new technologies that are coming up that promise it, but nothing that has been done at that huge scale. So what we have done here is we have taken one of the emerging technologies, and then we are trying to sort of parallelize it and have a consensus algorithm done in a manner that can be sharded so that we can hit at least, if not a million, at least 500K TPS. So far, we have managed around 50 to 60,000 transactions per second in the lab that we have been doing. But again, if you can actually be very creative about what you do on-chain and what you do off-chain, you can actually achieve the sort of throughput by limiting the number of transactions to blockchain to only those that actually need veracity and that actually needs content authentication and that needs financial transactions. So that's how to do content authenticity again. So if I am uploading some content now, imagine if I can actually crowdsource this and other people can then vote up on the content or vote down. That way the content automatically gets authenticated. Right now there's no way for us to do that in Facebook. Yes, a post bubbles up, a post bubble down, but there is no way where I can say that, okay, if I have written a particular content, then the facts that I'm actually putting in there is actually correct or not. Blockchain can help solve that, because in blockchain, once you say that, okay, I am voting for this content, that's recorded, and you can never go back on it, and it sort of adds reputation to the content, and it adds more credibility to it. So that's that. Telecom sector. So not a lot has been talked about telecom sector, but telecom is one sector that can benefit a lot from the use of blockchain technologies. There's several problems with telecom sectors, like DNS attack, security breaches, again, the in-house downtime and all the time it takes to make all of those transactions, and the roaming frauds. They are actually the biggest problem that plagues this industry. So in telecom sector, one of the projects that we have worked on, and we are partnering with ATNI here. So what we are trying to do is we are trying to create a marketplace for telecom operators. Let's say I'm a telecom operator and I do not have a very good coverage in a particular area of Singapore. And let's say some other telecom operator has a really good coverage there. What if I can actually buy that data from that other operator? And what if I can actually do the entire data reconciliation on distributed ledger technology? I mean, that would open up a lot of potential. And very slowly, Wi-Fi is, or the ability to connect is being considered as a very, very preliminary facility that you need to have. According to some estimates, the overall cost for people not being able to connect when they roam about is around $40 billion. I mean, that's just a statistics, but that's a lot of money. And if you have a building or a real estate where you can say that besides water, electricity, gas, I'm also going to give you good Wi-Fi, and I'm going to give you like, a complete coverage, that immensely increases the potential of that real estate. So how is blockchain coming into the picture? How is distributed ledger technology coming into the picture? So distributed ledger technology here pretty much helps you solve the entire data reconciliation problem. So if I am providing this data, then I am going to have one node running on my own, the real estate or wherever I'm running it. Plus, it's going to get connected to AT&T or Verizon or Singtel or whoever am I using it. And then I create this entire marketplace where people can come and they can bid as to what they want to pay for per gigabyte of data, what sort of technology that they use, all of it. And then this is just so as to say the start. Once we have LTE coming in, and once we have all of these small IoT devices becoming more and more LTE compliant, this is going to open up a whole new opportunity space for everybody. And then the entire reconciliation happens via smart contracts. The payment gets made automatically, and you don't have any of those long auditing and invoicing and all of those that you earlier need to go through. So that's for telecom. So when we were developing all of these, like the health sector, social media, we have also done quite a few projects in fintech space, in e-commerce space. There are a few things that sort of came out to us. Irrespective of which industry it is, there are some components that almost everybody needs to solve. And then we realized that these same problems come in a different flavor, in a different vertical industry or a different use case. So one is obviously the identity management. I mean, irrespective of where you're building your solution, you need an identity management system. You need a user to be able to sign up to your platform. You need a user to be able to interact with your platform. And you need a way that they can manage their crypto identity in a seamless fashion. Now, most users are not very crypto friendly. They do not understand private keys. They do not understand how the entire signing of transaction works. And that is where our identity management solution comes in. So we have developed this in a manner that it can plug and play into pretty much any blockchain framework. So for example, if you want to use Fabric, you can use our solution adapted to Fabric. If you want to use Ethereum, you can use a solution adapted to Ethereum. But it's a solution that has been devised in a manner that can support multiple blockchain frameworks based on what suits best for that particular use case or that particular problem. Then document storage and sharing. I mean, document is probably not the best word. It's like information storage and sharing. Blockchain really shines when you want to do a permissioned share of information and you want to keep a track of which users shared what with whom. We have seen this same pattern appear in different use cases, in the healthcare as well, in e-com as well, in social media as well, and in telecom as well. So we have built a solution, again, which can plug into any blockchain framework that you use and can give you a head start if you want to build an information sharing and information access platform. So you choose a blockchain platform, then you use a solution, and then you can have your own information sharing manner the way you want to, and it's completely customizable. And then a multi-blockchain connect platform. So what we are seeing right now is most of the blockchain architectures, there's going to be a permission distributed ledger that's going to be very private, and it's probably going to have just a consortium of parties joining it. And then they want to anchor this data on a public blockchain, maybe like Ethereum or Stellar or maybe EOS. And then you need a way to create a bridge between the permission ledger and the public ledger. And that's what we have built. So let's say you want to have all of your business logic in-house. You do not want to expose all of that. But at the same time, you want to maybe take a snapshot of what your logic was and encrypt it and then store that on Ethereum so that nobody can challenge you. Plus, at any point of time, you can prove that you have never tampered with the data. And that the data is genuine. So that's where this bridge comes into picture, where your permission ledger would interact with the bridge. It'll take a snapshot or something, and then it'll anchor into whichever blockchain you want to, maybe Ethereum, or maybe Stellar. So those are some of the solution accelerators that are matured enough and that have already been applied into multiple use cases, plus we are building on several others. Yeah, I mean, that's pretty much the end of my presentation. That's my contact info if you need to get in touch, and I'll open to questions now.
Ankur, that was definitely a brilliant presentation and a lot of compelling use cases. So a lot of the use cases that you've covered, we've seen them over the years and they've slowly started evolving and moving to development, right? So we also, as a technology company, we've run into a majority of them before. And then one area that we've always seen, especially when people move from adoption to blockchain, is in a blockchain ecosystem, there are two users. There are validators, and then there are actually people who use the ecosystem, right? So could you take an example of one such use case and say who are the validators of this network? Or have you ever done any sort of a similar analysis in identifying the validators of a particular use case that you just described? Who are going to confirm transactions that goes inside this particular use case that you would have considered?
So that's a very good question. And it varies. So for example, when you're running a permission node, the telecom example, where we are creating a marketplace where every telecom operator would run their own node. And in that case, there are no validators needed because the channel gets established between you and me. So once we agree to what the deal is between us, it stays between us. We are using blockchain there for data reconciliation specifically and nothing else. If I take the other use case, for example, that's a public blockchain. There we have our economy modeled in a particular manner that gives incentive to people who are maintaining the network, so as the miners, so to say. So the validators change. I mean, in case of permission private ledger, you don't really need a validator. In case of public one, yes, you have to come up with an incentive model that actually ensures that you have people maintaining those nodes.
So in most of the permissioned implementations, you really don't think about incentivizing the validators. The incentive is to use the system then.
It depends on why you are using the distributed ledger here. So for example, if you're using distributed ledger for data reconciliation, and if you and I negotiate a treaty or whatever contract that we want, we don't even want a third party to know what is happening between us, right? It's very private. So there I would not want to disclose, or I would not have validators there supposedly. Whereas in a public chain, or let's say in Ethereum blockchain, you need validators for maintaining the network and to give you that credibility. So yes, in permissioned ones, we have not seen a use case coming where you need a specific validator. People only join that ledger once they have been validated, once their authenticity has been confirmed.
All right, thank you so much. Any other questions from the audience?
Yes, two questions, but the most important. You talk about storing security data inside the blockchain, for example, for the healthcare, critical data, sensitive data, sorry. So this means that you need to encrypt for sure, because the blockchain at that point will be available in many nodes. So we have talked about this, and we think this is very risky, in the sense that the risk is impact per probability. Probability is very small, but if it happens that the keys being stolen, the impact is enormous, because the entire blockchain is available to everybody. So someone can decrypt the content of healthcare health data. So for this reason, we think this is a very critical, and many other use cases in which you manage personal data, sensitive data, even if they are encrypted with the keys outside the blockchain.
Okay, so that's a very relevant point. But as such, we don't store data on the blockchain. I mean, the data is stored in some sort of a distributed or decentralized storage, and then we keep a reference of the data in the blockchain. That's number one. Number two is not all data is encrypted using the same key. So my data is encrypted using my key. Your data would be encrypted using your key. So if my keys ever get stolen, it's only my data that's going to get breached. Okay. Then we don't store my complete data in one particular node. What we do is we would shard my data and then store it in multiple nodes, and at the same time replicate this node, so that, like, in case one node goes down, I can actually stitch my data from all the other nodes, bring it together. So that way we never have a single point of failure. And the encryption of the data only happens when it reaches the client side using your own key per se. So, like, does that answer your question?
Any other questions from the audience? All right then. Thank you so much, Ankur,
Thank you.
for the presentation. Very insightful.